Okay, this is, well, we call it section 8.2, but it's about the Pythagorean Theorem and its converse. Now let's talk about Pythagorean Theorem just a little bit. Number one, you're supposed to be very familiar with Pythagorean Theorem. Okay, this is, we're in high school, 10, 11, 12th graders, whatever, 9, 10, 11th graders. And Pythagorean Theorem is supposed to have been mastered in the 7th, 8th grade. You're supposed to have known that and mastered that. And so we're using something you know, and we're going to extend it just a little bit because we're going to take the converse and work on that. And then we're going to talk about something called Pythagorean triples. Okay, but first of all, let's just review this. Pythagorean Theorem and its converse. Let's talk about Pythagorean Theorem. If there is a right triangle, then the sum of the squares of the sides, let's put that sides of the, let's change that to legs. Okay, that would make more sense. Legs equals the square of the hypotenuse. So we definitely have to have a right triangle if we're going to have a hypotenuse. Now, what is that saying? Let's look at this drawing of a right triangle. I'm going to label this in a very special way. And I want you to remember this label, and I want you to start learning how to label things this way because it's going to make a whole lot more sense when we start getting to the rest of this section on right triangles and we start talking about trigonometric ratios and things like that. We're going to label this, and we're going to label the right corner with the right angle. We're going to label that C. That corner is point C. Okay, and I'm going to emphasize that that is a point. Okay, that's a point. A is a point. B is a point. Okay? Now, those are all capital letters because points are named with capital letters. Now, across from point C is a hypotenuse, and we're going to name that little c, or segment C. Okay? Little c, we can do that. And across from A, we're going to name that leg little a. And across from B, we're going to name that leg little b. Now, does it matter where we put point A and point B? No. I just don't want them to be the right angle right now. I want them to be the other sides for what we're going to be doing. Okay? So given that, now if you start mixing this up and you start putting capital letters for everything, all of a sudden you're not going to know what you're talking about. And when you got a test, and when I put things on the board and you see the lectures and things, you're not going to know what things are. I'm going to start talking about little a, and you're going to be thinking, oh, he's talking about point A. Because that's what I got. I'm going to start talking about point A. You'll be thinking I'm talking about segment A. So keep these things straight. And if for some of you I do this backwards, well, that's my brain right now. And so what this means up here is the sum of the squares of the legs. The sum of the squares of the legs. So if we take the legs, A and B, and we square them and we add them together, which is the sum, we're going to get the square of the hypotenuse. There it is. A squared plus B squared equals C squared. Or we can also write it another way. C squared minus A squared equals B squared. C squared minus B squared equals A squared. Okay? Now, thing to remember, C, little c, is always a hypotenuse. It is always the longest side, and it does not touch the right angle. For some reason, some people have some difficulty in identifying the hypotenuse, or C. So I'm putting this down. C is the hypotenuse. C is the longest side. If I'm given 3 letters, get 3 numbers, or 3 links, and no drawing, guess which one is the hypotenuse? It will be the longest one. Okay? And it does not touch the right angle. C doesn't touch the right angle. Got it? A and B do. The legs touch the right angle. That's why they're called the legs. Okay? Got that? Alright, so the way to look at this is like this. The other thing is, to remember is, all these Pythagorean Theorem equations, they talk about things squared. Well, we don't really want things squared, do we? we'd like very much for them to be C and A and B. So when I find C squared, in order to use it, what do I got to do to it to get C? What? Yeah, I got to take the square root. If I don't take the square root, I can't do any arithmetic with it. Oh, I can, it's just going to be wrong. When I find B squared, what do I need to do to it to get B? I need to take the square root. When I find A squared, what do I need to do with it so I can use it as A? I need to find the square root. So, make sure, okay, hypotenuse. C is always hypotenuse. It is along the side. It does not touch the right angle. And when you find C squared, B squared, and A squared, make sure it's not going to have a little symbol on it that says, oh, this is squared. You got to remember it so that you take the square root of those so that you can use them in your calculations. Okay? So what we're going to do is we're going to do some straight little samples here real quick. 3 or 4 samples. Then we're going on to the Converse and do some samples and get done with this. Okay, now we're going to be looking at Pythagorean Theorem, some sample problems just using the Pythagorean Theorem, not as Converse. You'll notice that I wrote the equations we'll be using, c squared equals a squared plus b squared, or c squared minus a squared equals b squared over here. And we've got 4 examples, so let's look at them. Here we have a right triangle. It's an isosceles right triangle, okay? Hypotenuse is C, the legs are A and B. So what are we going to do? Let's use it, and let's look at this equation and replace it. What's C? It's x. So we're going to put x squared in there. What's A? It's 3, so we're going to put 3 squared in there. What's B? It's 3, so we're going to put 3 squared. So x squared equals 9 plus 9. X squared equals 18. I don't want x. X squared, I want x, so I take the square root of it. Square root of x squared is x equals the square root of 18, which is 4.24. So what we've got here is x equals 4.24. All right? That's the first one. Pretty simple. Next one is a little different. Here we have a right triangle. The hypotenuse is given to us over here. A is given to us. We're supposed to find the B. It's labeled x. Okay? So let's use this equation and replace it. What's C? It's 15. So 15 squared minus what's A? It's 9. 9 squared equals, what's B? X squared. 15 squared is 225. Minus 9 squared is 81 equals x squared. 225 minus 81 is 144 equals x squared. But I don't want x squared. I got to have x. So what do we got to do? We're going to take the square root of x squared is x equals the square root of 144. Now I happen to know in my calculator confirm it that square root of 144 is 12. So x equals 12. By the way, that is a 3, 4, 5 triangle. Okay? Divide every side by 3 and you get 3, 4, and 5. So that's a 3, 4, 5. Oh, wow, that's a Pythagorean triple. All right, the next problem. Notice again, we're given the hypotenuse. We're supposed to find one of the sides, so we're going to use this. Hypotenuse is 65, A is 25, and B is x. So we take this equation, we replace. C is 65 squared minus A, which is 25 squared, equals B, which is x squared. So 65 squared is a whopping 4,225, minus 25 squared, which is 625, and that equals x squared. We take this, we get 3,600 equals x squared. I don't want x squared, I got to take the square root of it. So we take the square root of it, we get x equals the square root of 3,600, well, which happens to be 60 multiplied by itself. So x equals 60. This side over here equals 60. Wow, this happens to be, this one here is a 3, 4, 5. This one over here happens to be a 5, 12, 13. Okay? 2 of the most frequently used Pythagorean triples there are. What? They're whole numbers that when you use them for the legs and you put them into the Pythagorean theorem, they equal each other and they create a right triangle. 5, 12, 13, 3, 4, 5. How do you know this one's a 5, 12, 13? Well, divide everything by 5. Divide 25 by 5, you get 5. Divide 60 by 5, you get 12. Divide 65 by 5, and you get 13. Okay, now let's look at this one. This one is, we're given the length and the width of a rectangle. And we need to find the diagonal. Oh, well, the diagonal happens to be the what? Hypotenuse. So we're going to call that C. We're going to call these A and B. We're going to use that equation. Oh, wow. C is x. So we say x squared equals 33 squared plus 16 squared. X squared equals 1,089 plus 256. Add those together. X squared equals 1,345. We don't want x squared. We want, you got it, x. So we take the square root of both sides. X equals the square root of 1,345. X equals approximately 36.76? Yeah, I think so. 36.76. Let's try that and see. Make sure. 36.76. Nah. It's 36.67, I believe. Yeah, let's try that one. 36 point. Got those mixed up. 6, 7. So this is going to be 6, 7. Okay? That's how to use Pythagorean Theorem. Now we're going to look at its converse. Basically, given three numbers, three measurements, will they make a right triangle?